You're watching The Beginner's Guide, powered by the Christmas Light Academy, the #1 employee training system for Christmas light businesses. Tired of wasting time training new hires? Now you don't have to. Give your team the tools they need to succeed without the headache. Click the link below to unlock a special offer available only here.
All right, so we've covered power distribution, but now let's talk about data flow, how the system communicates with the lights, and what you need to know to keep everything running smoothly. Permanent trim lighting systems use data signals to control the lights, telling them which colors to display, when to turn on or off, and how to run effects. Unlike power, which can be injected at multiple points, data must always flow in one direction, from the controller to the last light in the system. Each system has a maximum number of bulbs per data line before signal quality starts to weaken. While this varies by brand, most systems can support up to 300 to 500 lights per data run before needing a data booster or a second output from the controller. To ensure proper data flow, here are a few key things to keep in mind. Always start at the controller and make sure data flows away from it in one continuous path. Avoid sharp bends in the data wire, as this can cause signal interference. If you need to split data, use an approved data splitter, not just a wire splice. If data flickering or failure occurs, check connections and ensure you haven't exceeded the system's data limits. A data splitter comes in handy when you need to run lights in multiple directions from a single data source. For example, if you're running lights across a house and need to branch off to add lights to a dormer or peak, a data splitter allows you to send signal in multiple directions while keeping everything synchronized. Another thing to watch for is long gaps in wiring. If the jumper section you are running is more than 50 feet to the next lighting section, you may need to install a data booster in that jump to ensure a strong and consistent data signal. Since the controller communicates with each light individually, long breaks in the wiring can weaken the signal, causing issues with lighting effects or synchronization. A data booster refreshes the signal, making sure everything works properly. If a project requires more bulbs than the system's data capacity, there are two ways to extend the signal: using a data booster, which refreshes the signal at a midpoint, allowing for longer runs; splitting the system into multiple zones by using separate controller outputs to manage different sections independently. Understanding data flow is just as important as power management, and both need to work together for a smooth installation. Every brand has specific product specs and guidelines for data capacity, boosters, and splitters, so we won't go into exact details here. The system you install will have its own recommendations, and it's important to follow those instructions to ensure everything functions correctly. All right, that wraps up data flow and connectivity. Now, let's move on to Module 4, Staying Safe on the Job, where we'll go over ladder safety, roof terminology, and best practices for working on different surfaces.